All right, this is our assignment, well, our notes from Monday 1:11. And it's probably one of the more difficult sections that we have just because it's brand new to us. And it takes, there's not any math really to do to it. It's more of some memorizing some stuff, okay? And this is what we're talking about in terms of memorizing is what is the end behavior. And the end behavior are just what you'd think of the ends of the graph. Okay, where's it going and how do we describe it? So let's look at first how they're describing it, and then we'll look at all of the different combinations there are. What this basically says, and I don't like the way they've phrased it right here. I always like to look at it as x does something, what does, and think of this f of x as the y value, what does y do, okay? So as x in this case, if I follow this graph, as x goes to the right, see how I'm going to the right as I trace it, where does the function, where does the y value go? The y value goes up and up and up forever. So we say as x goes to the right to positive infinity, the y value, but we call it function, goes to, it went up forever, and that is positive infinity. So as x went right, it went up. On the other side, as x goes left towards negative infinity, it goes down forever and ever and ever. So we say as x went to the left towards the negative infinity, the function, it went down forever. It went towards negative infinity also. And so you can start to see, let's look at this one right here. Okay, we'll talk about degree and lead coefficients in a second. As this next one, as I go this way, as x goes to positive infinity, where did the function go? And you can see it's clearly going down, and that is the direction of negative infinity. And then on the left-hand side, as x goes to the left, goes towards the negative side to infinity, the function went up, and up is positive infinity. So hopefully you're getting the idea. I'm not going to write all these down. They've got them written there for you, but you can see this one right here. As we go to the right to positive infinity, it goes up to positive infinity. As we go to negative infinity, this left side goes up to positive infinity. So as x goes to negative, the y went to positive. And over here it does the opposite. As x goes to positive, it goes down to negative infinity. And as x goes to negative infinity, it goes down to negative infinity. Okay, so that's the notation, and it's going to take you a while to get used to that. You may have to refer to this chart. I actually have this chart with the assignment, okay, so you can use that and pull it up as needed. Now, let's look at this lead coefficient and the degree stuff. Remember, degree is the highest exponent. So if your degree is 1, 3, 5, 7, 9. So if your highest exponent is an odd number, okay, what that means every single time, odd degree functions do one of two things. The ends will always go in opposite directions. It'll either be that or it will be this, okay? Always. Odds always do that. And so here's an odd, and look, one's doing this, ends going in opposite directions, the other one's doing this. So how do you tell which one it is? And there's kind of a key thing you focus on. You look at the lead coefficient, the number in front of that first variable. If it's positive, the right-hand side always goes up. Okay, look at even down here. If the lead coefficient is positive, the right-hand side goes up. If the lead coefficient is negative, the right-hand side will always go down. Negative, right-hand side will always go down. And then you just have to remember that because it's odd, like in the first two cases, if the right-hand side goes up, the other one has to go down. Or if the right-hand side starts by going down, the other end has to go up. Then on evens, they always go the same direction. So if the right-hand side goes up, the left-hand side goes up. And if the right-hand side goes down, the left-hand side goes down. So that's for even degrees. Even degrees, they make this field goal shape, or it's a cup that's turned upside down. Okay? Whereas odd degrees always make these S shapes, if you think of it laying on its side. And we can tell all of that just based on whether its degree is an odd degree and what its lead coefficient is. So let's say I've got this problem right here. The first thing you want to do is check and make sure that you are in standard form. Okay? Otherwise, you can't figure out what your degree is and what your lead coefficient is. So you check. It goes 4, then 2, then 1, then none. So we're going in descending order. We're in standard form. So let's list our degree here. Degree. It's even. We don't have to state that it's 4, but it is. Remember, the degree is the highest exponent. Okay? Now, as soon as I know it's even, I know that it either makes the field goal or it's upside down cup. Pouring out the water. Either it can hold water because it's positive, or it can't hold water because it's negative. So we look at our lead coefficient. We don't have to state the lead coefficient, but the lead coefficient is negative. That tells us everything we need to know. It's a negative 0.5 if you want to know the actual value of it. And because it's a negative number, I know right away the right-hand side has to start by going down. And because it's an even exponent, I know the left-hand side goes down. And I can describe it, okay? I could say, okay, so as x went to positive infinity, as I went to this direction, where'd the function go? It goes down. Well, that's negative infinity. So f of x went to negative infinity. And then in the other direction, as x goes this way to negative infinity, that's our negative side of the graph. Where'd the function go? Well, it went down also. So it also went to negative infinity. They both ended up going down. And we've just described it. We didn't have to graph it, but it certainly does help to make a little sketch. Let's look at this polynomial. Again, we are in standard form. That's good. Let's see our degree here. Highest exponent, 3, so it is odd. Lead coefficient. It's just got a negative sign out front, and that means it's a negative 1. So it's negative. I'll write what it is right there. Now, as soon as I notice that it's odd, I know it's either doing this or it's doing this. Okay, how do I tell? Lead coefficient. Negative, that means the right-hand side goes down. That means it's this one. And so if I draw my arrows as x goes this way, the y goes down. So I can say as x goes to the right to positive infinity, the function goes to negative. It goes down. And then the left-hand side, as x goes to negative infinity, where does it go? It goes up. So the function goes to positive infinity. All right, get another example here. Standard form already. If it's not, we have to move stuff around. Degree 3, I shouldn't have to put that though. I'm just going to put degree odd. Right away, again, I know ends do opposite. I don't know what the middle looks like. I just know one end goes up, one end goes down, or vice versa. Lead coefficient looks like a positive 0.25, so we just write down positive. Okay, and so that means the right-hand side goes up, so it's this case right here. And so as x goes this way, it goes up. So it goes, x goes to the right, positive infinity. The value of y, or the function, went to positive infinity. And the x as it goes to the left, these x's you always write in that order. Where'd it go? It went down. So down is negative infinity. Okay. Here's what your assignment looks like. Okay. So describe the end behavior. So that's going to be, you're going to have two statements that you write for this. You're going to say, okay, as x goes to the right, to positive infinity, I should put. Then the function did what? Did it go up or did it go down? Positive infinity or negative infinity? And you'll also have another statement. As x goes to the left, f of x did what? Did it go up, positive infinity, or down to negative infinity? So two answers kind of to describe each end. And then in 5 and 6, you just have to describe the degree. So for degree, you have to choose or figure out, is it an odd or even? It's one of those two choices. And then the lead coefficient, you're going to have to decide, is it positive or is it negative? And you should be able to tell just by looking at the graphs. Okay, so two answers for 5 and 6 as well.